Alright, so today we're going to be going over cracking WPA2 using the tool AeroDump coupled with AirPlay attack-in G. And then we're going to be viewing our output using Wireshark. WPA2 has about 3 current attack vendors that are used in modern society, that being a EAPOL capture, manipulation using PMKID, as well as capturing the WPA2 password using evil twin attacks, evil fissure attacks, or any other way to attempt to get the user, aka the victim, to type in a plain text password. Today, since this is a beginner to intermediate level tutorial, we're going to be going over each step in depth, what you need, how to do it, and why this works the way it does. So without further ado, here we go. The first thing that you're going to need is a card that supports monitor mode. I've left a link in the description to a great write-up by a man who creates Realtek drivers. He goes over multiple Wi-Fi cards, and you can make your own decision as to which one you wish to pursue. The first command that you're going to want to use is iwconfig. This is what's going to allow you to actually see your card within your operating system. As you can see here, the current mode is in manage mode, which means it is currently being managed by our operating system. Every operating system has a default way of handling Wi-Fi connections. Within Linux, especially Debian Linux, it's going to be your network manager, which can be seen up here. As you can see, we're seeing some Wi-Fi interfaces here, as well as my wired connection to my VM. So our first step is going to be getting this into monitor mode. There's going to be 4 commands that we're going to run to do this, and they are as follows. So we're going to run sudo airmon attack-in-g check kill. What this is going to do is it's going to run through your Linux operating system and check and see if any processes are going to interfere with your wireless card. As you can see here, it found the WPA supplicant, aka the wireless manager, and it killed it. As you can see, it's no longer running. Then there's going to be a group of 3 commands to place our card into monitor mode. It's going to be sudo iplink set, and this is going to be our interface name, which as you can see right here is WLAN0, set WLAN0 down. Next one's actually going to place the device into monitor mode. Sudo iwdev WLAN0 set type monitor. Now, since we set our WLAN to be down, we have to bring it back up. Sudo iplink set WLAN0 up. Now, if we type iwconfig again, we can see that our card is now in monitor mode. What this means is that our interface is going to be able to passively sniff and capture all of the raw 802.11 data, aka our wireless data that we're concerned with. So stage 1 has been complete. We have our card in monitor mode ready to go. The next thing we have to do is use the tool called AeroDump. AeroDump is part of the AirCrack suite, and it allows you to view and monitor raw 802.11 traffic. What we're going to do is we're going to do what I like to call a broad scan. My card supports 2.4 gigahertz and 5 gigahertz capture. If you're not sure what that means, most access points nowadays in home networks have the ability to have a 2.4 gigahertz side and a 5 gigahertz side. Wireless access points put a thing out called beacon frames. It's part of the 802.11 standard and is how access points advertise out to clients what their mode is, how many channels they have, what they're operating on, and what they're capable of. So, with AeroDump, we're able to look for these beacon frames, and we're able to see the surrounding access points in an area. To begin, I'm going to start the AeroDump survey using a broad survey. Sudo AeroDump attack-in-g. Let me mute my Discord real quick, one moment. Okay, sudo AeroDump attack-in-g, and now we're going to specify the band we wish to capture on. AeroDump by default will only look at 2.4, aka the Bravo and Golf bands, so we're going to specify every band with TAC band ABG. Now we have to put our interface at the end, which is WLAN0, which is the one that we set into monitor mode earlier, and we're going to hit enter. You're going to see a ton of different things flow on the screen. In the top left here, we have our channel number, which is constantly hopping. Your interface will natively do this because it's trying to scan through the Wi-Fi spectrum. As you can see here, we have the human readable names, which is what you would see on your phone whenever you're trying to connect. We have the encryption type, our cipher, the way that is authenticating, aka a pre-shared key, which is WPA2. And then on the very, very left here, we have the BSSID, which is the hardware address of that access point. I'm going to go ahead and stop this capture using Control C. Now we get to look at our capture here. I've blocked out everything else just so I can respect the privacy of my neighbors, but the one that we're concerned with is my access point. As you can see, it has the strongest power reading. Closer to 0 means stronger. As you get negative and more negative, that means it's a weaker signal. It's operating on channel 36 using the CCNP cipher with WPA2 encryption, and our SSID is FLORAT. That's mine. So, for step 2, we need to capture the data of just this access point. The way we're going to do that is we're going to run AeroDump again, but with some different flags set. We're going to replace the TAC-TAC band, since we already know what band it's on now, and we're going to replace it with the TAC-TAC channel argument. For here, we're going to do TAC-TAC channel 36, since our access point is on 36. Additionally, we're going to add in the TAC-TAC BSID flag, since we know the BSID of our access point that we're going after. Toss that in there. Cool. Now, if we want to save this to a file, we have to actually do a TAC-W argument and then a name of our file. I'm just going to call it floor_rat. Okay, we have our channel locked, we have our BSID locked, and we're writing it out to a file along with our interface that we wish to use. I'm going to go ahead and hit enter. So as you can see here, we're just filtering on the one access point. On the top here, we have our BSID and a client device, also known as a station. These are going to be your actual Wi-Fi devices connected to the access point. In this example, it's my cellular device. What you're going to do now is you're going to leave this running. This needs to stay open during the attack. Our goal here is to kick this device off of the network using what is called a DeAuthentication frame. It's a part of the 802.11 standard, which allows access points and stations to leave a BSS promptly and without any hassle. So, to run this, we're going to do sudo air replay, or airplay TAC-NG. We're going to use a couple arguments. TAC0 indicates that we're going to do a deauthentication attack. We're going to send 164 session of deauthentication packets. If you put a 0 here, it will go indefinitely, and it will be effectively a DOS, which is not what we want. TAC-A to specify the access point we're going after. We're going to go over here and hit spacebar to pause so I can copy here. So right-click copy, paste that in. TAC-C for the client, which is this station right here. And then WLAN 0. I'm going to hit enter. It's going to ask me for my password. Just like that, we captured a WPA handshake. What this means, and if you were looking at your device when you did this, is that it would be temporarily knocked off the internet, and if your device has that that network saved and it has the automatic reconnect function enabled, it means that you're going to automatically try and connect to that wireless network. As you can see here, my phone did. It says notes EAPOL, which is a wireless handshake, and it also tells you up here that it captured a WPA handshake for that station's MAC address. Now I can go ahead and stop this AeroDump, and I can move on to the final step. So now that you have your EAPOL, there's a couple ways to double check it. The first one is using the aircrack command. So if I type aircrack TAC-NG, you can do sudo in the front if you need to, and then the capture file, which in this case is florat2.cap. It'll actually tell you, hey, for this BSID and this ESID, you captured one handshake. If you don't see this in here, it's a strong indicator that you weren't able to capture all the necessary frames to get a full handshake. The second way that we're going to look into this is using Wireshark. So using Wireshark here, I'm going to open the capture file. So it's going to be florat tac2.cap. I'm going to type in the filter up here, EAPOL. As you can see here, we got messages 1, 2, 3, and 4. At the bare minimum, you need messages 1 through 3 to do this type of attack. This contains the A-naughts, the S-naughts, and the GTK, as well as the PTK, aka the pairwise transient key. The way the aircrack works is it tries to brute force the PTK and GTK, enabling you to effectively find out the plaintext password when ran against a dictionary. Okay, so how do we do that? What you would typically require is a very large dictionary file to run this against. So you can download these online. Kali Linux has one built in called the RockU word list. You can find PSK dictionaries all over the internet. For this example, I'm just going to make a super small one and show you what happens whenever that password is in the dictionary file and whenever it is not in the dictionary file. So I'm going to quickly create one using the touch command. So I'm just going to call this test dictionary. And I'm going to echo in some random passwords. So we'll put hello into there. We will put hi. And we will put password into there. As you can see, we have hello, hi, and password within this file. So, to crack this capture file, we're going to do sudo aircrack tacking g. The capture file name, which in this case is floor underscore rat tag02.cap. It will always be a .capture file that we are interested in. We're going to use tac-w to specify a dictionary. I'm just going to go ahead and enter my test dictionary file. If I hit enter, it's going to run through all of your keys. As you can see with my computer, we're going at 102.6 keys a second, and it says key not found. What this means is that within your dictionary file, there was not a plain text password that happened to match the wireless network of which you're going after. I'm now going to echo my wireless password into this file. And I'm going to run it again. Boom! As you can see, running it against the updated dictionary, it was able to crack the master, the transient, and the EAPOL HMAC. What this means is that if you place this password into your device when you're trying to connect to that network, it will let you in. Additionally, if you were trying to view this traffic in Wireshark, you would put this password into Wireshark and it would enable you to see layer 3 up in terms of traffic. That is all for now. Further topics such as PMKID, as well as phishing-oriented scenarios, and eventually the key reinstallation attack for Wi-Fi will be discussed in later videos. Please let me know in the comments if there's anything you would like to see, or anything that I can improve on, as I'm new to the YouTube game. Thanks everybody, and have a great day.